everyone, this is Disturbance, Devastation, and Ecological Outcomes in Halifax's beloved Point Pleasant Park by myself, Evelyn Ferguson, Kaylee Hicks, and Kaylin Collins for Dalhousie University. Okay, so we'll start with a little background. Point Pleasant Park is situated at the southernmost point of Halifax. It's the most extensive park in the region, spanning around 185 hectares. Its tranquil trails, woodlands, and invigorating sea breezes easily makes it a cherished natural space to many. It's important to note that the first to enjoy this space were the Mi'kmaq, who hunted, fished, held various celebrations, and traveled far distances to visit what they called Tukati, which is the Mi'kmaq name for Point Pleasant Park. It translates to spirit or power place. So, yeah. This history, unsurprisingly, is often overlooked and unrightfully outshined by its European history. In 1749, Edward Cornwallis originally sought out the land as a place for Halifax's settlement, but quickly realized its unsuitable terrain and developed it into a military fortress instead. Remnants of this former European settler history can be seen today, but its Mi'kmaq historical significance is unfortunately not as prominent, so it's extra important to acknowledge that. Hurricane Juan was no friend to Point Pleasant Park. It completely devastated its mixed Acadian forest ecosystem on the night of September 28, 2003. Joachim and others conducted a pre-hurricane ecological survey before Hurricane Juan on the place, which predicted it to be especially susceptible to extreme weather events and devastating tree mortality. Since the park's main species were largely coniferous, mature, and even-aged, which are factors known to increase tree vulnerability, it was inevitable for Hurricane Juan to leave a lasting impact and wipe out nearly 75% of the place's trees. Despite the devastation, a silver lining arose when Dalhousie's biology course, the one we're in right now, decided to study the disturbances seen at Point Pleasant Park. They collected data to better understand ecological succession in urban forests, and this presentation will interpret their regression analyses done by the former students on total density, average diameter and breast height, species richness, Shannon diversity, Pailou's evenness index, and population size for both dominant species red spruce and red maple. We will discuss the forest's observed changes over time and predict the likely outcomes on community metrics and dominant species density as the area continues its recovery from the hurricane. In this slide, I've included the associated null and alternative hypotheses for the 3 questions we were given in class that we aim to answer. So the first question is, how has the overall forest community changed over time? Why? And what can we predict will happen to the overall community as the forest moves towards its climax community? The second question is, how has the density of the dominant species in 2004 as well as the dominant species in 2023 changed over time? And what can we predict from what will happen to the dominant species as the forest moves towards a climax community? Question 3 is, how has the chosen community metric changed over time, and what can we tell and predict will happen to the chosen community metric as the forest moves towards its climax community? So these 3 questions will be discussed and aimed to sort of answer throughout this presentation.
Our study was conducted at Point Pleasant Park in Halifax, Nova Scotia, Canada. Measurements were taken annually during the last week of September to the first week of October from 2004 to 2023. Note that 2005, 2007, 2016, and 2020 were excluded due to Hurricanes Ophelia, Noel, and Matthew, and COVID-19, which prevented data collection. Data was collected at 6 replicate 20 by 20 meter sites located southeast of the Tower Road entrance to the park. The data collection sites were selected in areas with the highest hurricane disturbance to forest structure. All measurements were taken by Dalhousie University's Biology 2060 students, supervised by an instructor. All living trees greater than or equal to 2.5 centimeters in diameter at breast height were considered. Diameter at breast height was measured using a measuring tape to the nearest nanometer at 4.5 feet off the ground in one plane perpendicular to the stem. The species of all living trees within a site was identified, and the number of individuals of each species was recorded. These data were used to calculate total density, species richness, Shannon diversity index, and average tree size. Linear regression analyses were performed for each variable of interest using RStudio to assess whether ecosystem recovery has been linear.
To determine the change in total density in Point Pleasant Park over the years past since Hurricane Juan in 2003, regression analysis was used to acquire the data related to Graph 1. There's a strong positive relationship between the years past since Hurricane Juan in 2003 and the total density of Point Pleasant Park. Using this data, we can reject the null hypothesis, that being there is no change in the total density of Point Pleasant Park since 2003. The data allows us to determine the total density of Point Pleasant Park has continuously increased over time. To determine the change in the Shannon diversity value of Point Pleasant Park since Hurricane Juan in 2003, regression analysis was used to acquire the relevant data in Graph 2. There is a positive relationship between the years past since Hurricane Juan in 2003 and the Shannon diversity value of Point Pleasant Park. Considering this data, we can reject the null hypothesis, being that there is no change in the Shannon diversity value since Hurricane Juan in 2003. The data allows us to determine that the Shannon diversity value continuously increases over time. As seen in Graph 1, there is a continuous increase in density since 2003. Using the data retrieved from Point Pleasant Park as reference, we can see the total density of the forest increasing as time passes since Hurricane Juan in 2003. As seen in Graph 2 representing the Shannon diversity index of the park, once again, we observe a positive slope from the regression analysis. This allows us to determine that the diversity of Point Pleasant Park continuously increases after Hurricane Juan in 2003. Analyzing the data from both these graphs and their respective statistical tests, we can determine that the increase in both total density of the area and increase in Shannon diversity index, correlating to an increase in overall diversity, are due to the forest recovering after the effects of Hurricane Juan in 2003. As supported by the findings in NALE 2004, many tree species had a rapid regeneration time. Different tree species regenerating after Hurricane Juan is a finding consistent with the data provided by Graphs 1 and 2, as this is an indicator of recovery. When considering what will happen as the community moves towards its climax, we can conclude that the amount of density and diversity of the community will stabilize. As we get closer to the climax community, the density of Point Pleasant Park will not be climbing at such a high rate as it reaches its climax community. There is only a certain number of species the ecosystem can accommodate with the space and resources available, meaning that the density will stay relatively the same. When it comes to the diversity, once the density reaches a stable point, the diversity will stop increasing at such a high rate as well, because there's not as many species arising. Point Pleasant Park's diversity index, as well as the total density, will begin to look relatively the same through the years as it reaches the climax community.
To assess how dominant red spruce and red maple species responded to Hurricane Juan, two simple linear regression analyses were performed to explore the relationship between tree composition and time after the hurricane. First, there was a significant positive relationship found between the red maple composition and time. This suggests that the red maple composition has increased from 2004 to 2023. Secondly, there was a significant positive relationship between the red spruce composition and time, again suggesting that the red spruce composition has also increased from 2004 to 2023. Therefore, we can reject the null hypothesis that there is no significant relationship between species composition and time. The composition of red maple and red spruce can both be described by the equations listed in my script, and that is where y equals the respective composition of each species and x equals the year. It's important to note that although there is a significant positive relationship in both red spruce and red maple composition and time, which is expressed by the very small p-values, their R-square values are both very low, which means there is a high variability in the data, and it does not fit very well to the linear regression model as seen in both of the figures on the slide. This means that This model might not be the best or most reliable tool to make predictions about ecological succession in Point Pleasant Park. As Point Pleasant Park continues its recovery from Hurricane Juan, there are factors regarding succession that must be considered. As Joachim and others predicted, the urban forest gradually became dominated by mature, even-aged red spruce leading up to the hurricane, making it especially susceptible to devastation by natural disasters. HRM acknowledged that the appropriate regeneration measures must be taken to avoid the recreation of this vulnerable red spruce dominated ecosystem. A sort of hands-off approach that is letting natural succession steer Point Pleasant towards a climax community of densely populated dominant species should be rejected in favor of a more hands-on approach. This would entail the development of a diverse Acadian forest, promoting the planting of native species and encouraging structural heterogeneity to increase the urban forest's ecological integrity. Figure 1 and Figure 2 both show a trend of increased red spruce and red maple density since the hurricane. However, we do predict that these species will reach a steady state as the park attains its climax community. Although these dominant species play an important role in reestablishing the ecosystem and a mature tree canopy, it is fair to predict that a new and improved, if you will, climax community will be established due to HRM's efforts in building a more resilient, diverse ecosystem at the park.
To assess species richness recovery after Hurricane Juan, we performed a simple linear regression. Our study found a significant positive linear relationship between species richness and year with an R-squared value of 0.64. We reject the null hypothesis in favor of the alternative hypothesis that there is a significant positive relationship between species richness and year following the hurricane. Increased richness following an ecological disturbance is characteristic of succession theory as described by Moles and Cahill. This is due to an increased availability of resources for the recolonizing community. We found a significant linear increase in species richness over time, which is consistent with succession theory. Secondary succession typically involves an initial rapid increase in richness during the high successional stage, followed by a stage of thinning before establishing stability. The relative abundance of red maple, a shade-intolerant pioneer species found in the park, suggests that the forest is still in the early stages of succession following the hurricane. During the remainder of the high successional stage, it is likely that species richness will continue to increase. As the forest moves towards its climax community, the canopy will likely continue to develop and limit light, thus entering the thinning phase of succession and a related stabilization of species richness.
To conclude, Hurricane Juan has had a large impact on Point Pleasant Park. However, the data collected allows us to determine the park is in recovery based on the continuous increase of total density as well as diversity, and will eventually reach a stable climax community once again. Regarding succession, the forest is undergoing a substantial increase in both red spruce and red maple density. The regeneration measures taken will prevent an overtake of the dominant species red spruce, leaving behind a diverse Acadian forest. In the future, as the forest reaches its climax community, we can predict the red spruce to reach its level of maximum capacity. With respect to succession theory, the finding of increased richness after Hurricane Juan are consistent with this theory. As the forest reaches its climax community, we will observe the self-thinning process of succession theory as light becomes limited by the canopy of other species.